Hey everyone, today we're jumping right into one of the single biggest hurdles in AI right now. How do you go from a cool looking demo to a system that actually works in the real world under pressure? We're talking about the art and science of architecting production grade generative AI. And for this, we're drawing on some really fantastic architect level scenarios that were put together by Perplexity AI. So, this isn't going to be some high level theory. We're getting into the weeds with the tough, practical problems that AI teams are staring down every single day. And that really gets us to the absolute heart of the matter. It's this question right here. You've got two models. One is, technically more accurate, but the other one, it's way faster and a whole lot cheaper. So which one do you pick? The thing is, there's no single right answer, because in the world of production AI, every single decision is a trade-off. Okay, so let's dive in. Here's the game plan for running what I like to call the AI Architect's Gauntlet. First, we'll cover how you even measure your system. Then, we'll talk about optimizing it. After that, we'll scale it for the real world. And finally, we'll get into mastering the art of the trade-off. First things first, evaluation. Honestly, this is the bedrock of everything else. Before you can make anything better, you have to define, with cold, hard numbers, what better even means. You've got to have the right metrics in place, or you're just flying blind. So, let's start with a classic scenario. You've got a RAG system, that's retrieval augmented generation, where the AI looks stuff up before it answers, and you've got two different versions of it. How do you actually prove which one's better when you have a million users hitting it every single day? And boom, here's that classic dilemma. The fancier version, V2, is definitely more accurate, no question. But look at that, it costs 3 times as much to run. See, the real job of an architect isn't just to chase the highest score. It's to go to the business and ask, is that 12% accuracy bump going to make us enough money to justify paying triple the price? That's the real question. All right, let's look at another one. You've got a fraud detection model, and it's proudly reporting 92% accuracy. Sounds amazing, right? But the business is freaking out because a ton of perfectly good customers are getting their cards declined. That big, shiny accuracy number, it's hiding a massive problem. And this is the textbook precision recall trade-off. Our problem isn't overall accuracy, it's precision. When our model yells fraud, it's wrong too often. So as you can see, we can tune how sensitive it is. But the trade-off is crystal clear. If we make it less sensitive to stop bothering good customers, we're going to inevitably let a little more actual fraud slip through the cracks. There's no free lunch here. Okay, now for a problem that is super relevant today. Your RAG system is just making stuff up. It's hallucinating. A simple accuracy score is totally useless here. We need a much smarter, more sophisticated way to measure the quality and the truthfulness of the answers it's spitting out. This is how you do it. This is how you fight hallucinations with data. You take this fuzzy idea of a good answer and you break it down into things you can actually measure. Like, is the answer faithful to the documents it's based on? Did we even retrieve the right documents in the first place? That's context precision. By setting these super clear thresholds, we turn a subjective problem into a concrete engineering challenge. All right, so once you can actually measure your system, the fun begins. You can start optimizing it. This whole next section is about twisting the dials and pulling the levers to make your system better, faster, and of course, cheaper. Let's take a super common RAG problem. Your system needs to read and understand a massive 500-page PDF. Now, how you break that document up into smaller pieces, that's a process called chunking, is absolutely critical. If you do it badly, the AI is never going to find the answers it needs. And wouldn't you know it, it's that balancing act again, the semantic chunking method, which really tries to understand the meaning, gives us the best accuracy. But my gosh, it is painfully slow, 8 times slower. If you've got thousands of these documents, that's a total deal breaker. So the architect's choice here is often a compromise, something like hierarchical chunking that uses the document's own structure, chapters, headings, to be smart without that insane processing cost. This next one is all about working with what you've got. Imagine this. Your budget is tight. You have just one, good GPU, and you need to fine-tune a beast of a model like Llama 7B. The technique you choose here is everything. Looking at this table, the choice is pretty much a no-brainer. QLoRa uses this amazing trick called quantization. It's kind of like saving a high-res image as a slightly lower quality JPEG. You're using less precise numbers to store the model's weights. And the result? A massive 4x drop in memory needed, with less than a 1% change in performance. It is an incredible hack for doing big things on a small budget. Okay, time for the final challenge in our gauntlet. We've measured our model, we've optimized it. Now we have to make it work reliably for thousands, maybe millions of users. This is where we go from being a data scientist to a true systems architect. So how in the world do companies train these absolutely monstrous 70 billion parameter models? I mean, they can't possibly fit on one machine, or even a few. Well, a huge piece of that puzzle is a framework called Zero, which stands for Zero Redundancy Optimizer. The genius of Zero is that it intelligently splits up all the stuff that eats memory across a whole cluster of GPUs. At its most powerful stage, 0.3, it's not just splitting up the temporary data, it's splitting up the model itself. This gives you an incredible memory savings, but it introduces a new bottleneck. Now all those GPUs have to constantly talk to each other, so you're trading memory usage for network speed. Another trade-off. Finally, let's talk about the application itself. You're using a super popular framework, LangChain, and you need your system to handle 1,000 queries every single second. To do that, you have to make a really fundamental design choice right up front. And this choice comes down to using a chain versus an agent. Think of a chain like a recipe. It's a fixed set of steps. It does the same thing every time. And because of that, it's blazing fast and predictable. An agent, on the other hand, is like a chef. It can think for itself, it can use different tools, it can decide what to do next. It's way more powerful, but it's also slower and less predictable. When you're getting slammed with 1,000 queries a second, that predictable speed you get from a chain is almost always the right call. So, after running through this whole gauntlet, evaluating, optimizing, scaling, what's the one thing you should walk away with? What is the secret sauce, the core mindset of a great AI architect? It's this. It's so simple, but so important. Quantify everything. The best architects don't just know about their options. They measure the impact of every single choice. They don't just say, oh, it's faster. They say our P99 latency is under 150 milliseconds. They don't just say a model is better. They say we improved the F1 score to 0.92. Every decision is driven by real, hard data. And this right here, this is what it looks like when you put it all together. This is the kind of sentence you put on your resume. Notice how it weaves together all the things we talked about, QLoRa, RAG, Zero, into one statement that proves concrete business value. A 22% accuracy increase and a 60% cost cut. Now that is how you show your impact. So I want to leave you with this last thought. We've spent this whole time talking about making the correct choice in all these trade-offs. But in an industry that moves as fast as this one, the best technique today could be obsolete in 6 months. The true skill of an architect isn't about knowing all of today's answers. It's about building the systems and the mindset to keep finding tomorrow's. Thanks for tuning in.